All right, my name is Kenton Born. The primary thing I'm going to be talking about today is a tool I created called PSUDP, but I'm going to be covering a few other things along with it that I've been researching over the last year and a half. I've been working with Honeywell FM&T out of Kansas City for the last 2.5 years, and working on a PhD part-time on the side through Kansas State University. And in my school research, a lot of the stuff I've been looking at has dealt with covert communication, primarily in DNS. Before we get started here, though, I was up in Vegas about 4 months ago, and when I tried to log into Facebook, I was down on the casino floor about to give a presentation, and it came up with a CAPTCHA because I was in a different location. And I thought it was really interesting, and was curious if it wasn't a case of actual location-based CAPTCHA, because it actually came back and wanted me to type in "not winners." I thought that was very appropriate, being on the casino floor at the time. So I just thought that was really interesting and thought I'd share it, and thought it was pretty good advice. And at that point, I went up and played with my new Android phone in my hotel room for the rest of the night instead of gambling. So a basic roadmap of what I'm going to be covering. First, I'm going to go over a little bit of a DNS refresher for anyone who isn't real familiar with it. Talk about covert channels a little bit and DNS tunnels. I'm going to go over some of my past research a little bit. One part of that deals with browser-based covert data exfiltration over DNS. And then I'm going to talk about n-gram frequency analysis and visualization to detect DNS tunnels. And then I'm going to go over some of my current research, which goes over passive covert communication over DNS. The rest of it's primarily going to be active. And the difference between active and passive with my talk is when in active, I'm referring to actively generating packets, creating new network traffic, whereas passive, I'm referring to using traffic that's already going through the network. So you don't actually ever create a packet of your own. There are two types of covert channels that are generally talked about. You have storage channels and timing channels. Storage channels are basically where there's a location that is written to and read from. The easiest way to think about it is has a detectable effect on. And then there are timing channels, which is transmitting information through time values corresponding to the same data. You can either have a time interval where, say, you either send a packet or don't send a packet on that interval, and that represents a binary 1 or 0. Or you can have different time values representing different symbols, which gives you a little more bandwidth. There are a lot of different uses for covert channels. Most of you are going to be familiar with this, so I'm just going to go through it very quickly. One of the primary uses is bypassing network policies. A lot of people will use DNS tunnels, for instance, to get by paywalls, where they'll block the HTTP traffic until you pay them a fee, something like that. They're used for data exfiltration, command and control channels for botnets, that type of thing. And detection basically runs your entire gamut of tools, your network intrusion detection systems, firewalls, policy, traffic visualization. Most of you will be familiar with most of this, so we're going to kind of skip over this part. Now, DNS is essentially a transactional protocol that resolves domain names to IP addresses. It does do a lot more than that, but with what we're talking about today, this will pretty much get you by. You basically have queries where, for instance, your system is going to ask where is a domain name, in this case demonstration.example.com, and you're going to get a DNS response that gives you an IP address. And there may be more than one answer. They may give a list of 3 or 4 IP addresses, and we'll talk about that. But it'll basically give you an IP address. It is at 10.00.45. Down at the bottom, I have a bunch of different names that I'm going to be using throughout the speech, so just familiarize yourself with those. Everything in between the dots in a domain name is called a label, and the combination of all the labels is known as the fully qualified domain name. To the furthest left, you have the LLD, or lowest level domain. Furthest to the right is the top level domain. The furthest to the right, you have the domain. Everything to the left of that, subdomain. So just be familiar with those terms, because I'm going to be using them quite a bit. The actual packet format is as shown here. First, you have a header that has an ID in it, and then a bunch of flags. You don't have to know the specifics of that for this talk. And then this is sort of important. You have a bunch of what you see over at the far right, the QD count, AN count. There are 4 different types of resource records in a DNS packet. You have the question, which there's generally one resource record there. Then you have answers, which you may have 3 or 4, which I mentioned earlier. And then you have the authority resource records, which will give your authoritative name server. Then you have additional resource records, which will usually be things like glue records and that type. And then all the different resource record types generally have the same format that you can see below, with the question having a little bit less data. Now, there are a lot of different methods of hiding data in DNS, and a lot of previous presentations at Blackhat have talked about some of these. For queries, by far the most popular is hiding data in the subdomains, and I'll go over that more specifically in a little bit because it is so commonly used, and that is easily the highest bandwidth. But people will do things like hide information in the ID number of the packet. They'll go ahead and strip the ID number that was put in it and put their own custom ID that transmits information. You can drop back to like UDP and change the port and use a custom port to pass information. You can use timing, and you can use the various flags. Sorry, I thought I heard someone say something. And then for responses, there are also many different methods of sending data in DNS. A lot of people will use custom CNAME records. Once again, putting custom subdomains on there to fit data in there. You'll see a lot of the DNS tunnels right now will use text and null records because you can pretty much put arbitrary data in there and nothing cares. You don't need some specific format per se. You can encode it into IP addresses. You can once again use timing, and once again there are many others. Basically, what to get out of this slide is there are just a million ways of hiding data inside DNS traffic, and there really is no way of stopping them all. Instead, you want to mitigate the ones with the highest bandwidth. Now, exfiltration over subdomains, there are only certain characters allowed in domains. You have A through Z, lowercase and uppercase, 0 through 9, dashes and periods, which basically lends itself ideally to using base 32 or base 64 format. But you have to modify it slightly because there's 1 or 2 characters that don't work in domains. So you just change that character to something that is legitimate, and you use base 32 or base 64. And what you'll want to do is whatever data you want to exfiltrate to a certain domain, you'll set up some listener at that server, a domain that you control or that you can at least listen to, and you're going to take your data and you're going to base 64 it in this using this method, and then you're going to cut it up into the labels, place it in the subdomain, and send the queries to the server. And DNS just inherently is going to eventually deliver that packet to that server, where you can strip the data out. And then in the response, you can put whatever you need to send back to the client. Now, minimizing the traffic when you do this type of thing is important because you don't want to be shooting off 500 queries in a couple of seconds because of behavioral analysis. So typically, you're going to want to do some sort of data compression before you do this. But one thing you have to watch out for at that point is character frequency analysis, because compressing the data is going to increase the entropy of it. And once you do that, entropy is basically your randomness. And typically data is shown to all languages, including domains, which I'm going to show in a little bit, basically have certain characters that show up more than others. Everyone's played Hangman. It's on the same premise. So you want to make sure you're not sending too much random-looking data through it. And then encrypting the data is also important, but once again, you're probably going to be increasing the entropy there. There's a lot of popular DNS tunnels out there. Is there anyone out there that has actually created one of these tools? Okay, no one's in the house today, so I can say whatever I want about them and I won't be wrong. A lot of people have heard about Ozyman DNS. That's actually one that was created by Dan Kaminsky a couple of years ago, another one of the presenters here. TCP over DNS is another popular one, Iodine, DNS to TCP. Basically, all of these just allow you to create to send data back and forth. Most of these are used to tunnel things like HTTP over DNS, things like that. But you can they'll do it at the TCP layer, the IP layer. Ty Miller a couple of years ago showed reverse DNS tunneling shellcode. Heyuka was an interesting presentation. I'm not sure if I'm pronouncing that correctly, but it was a pretty interesting presentation where he put binary data in the domain name labels, which I'm not sure I'd recommend, but it was interesting that he was able to do it. And that lets you fit 8 bits per character instead of 5, which is, it's always helpful to be able to put a little more in there. And then he showed using the EDNSO extension to DNS, which for those of you who haven't heard of that, what it'll do, is allow you to extend the UDP packets, which for DNS they're typically allowed 512 bytes. With the EDNSO extension, you're able to make that up to something like 4,096, I think. And then it also spoofed packets across an IP range, which is really good for behavioral analysis because you don't have a flood of queries or responses coming from one system. So there's been a lot of interesting previous work, but all of this work is dealing with active traffic. They all create packets while they're trying to send data back and forth. While I was studying all these different DNS tunnels, they all had one thing in common. They all require foreign executables both on the server and on the client, which isn't always a good thing. It's something that can be detected. You may not have the required privileges to do this. And I was trying to think of a way of doing that, being able to do that type of data exfiltration, but do it more covertly and be able to do it on any system. So I started thinking about JavaScript. Which doesn't require elevated privileges on the system, and it exists just about on every system, and it doesn't have much of a fingerprint. All you'd really have to do is type something up in Notepad and load it up in the browser, which is already an executing process. And if you're able to get this bidirectional DNS traffic back and forth, that would be a pretty covert thing. Typically, a lot of people will look at HTTP traffic pretty heavily, but they'll usually overlook DNS a little bit. So the problem is that JavaScript doesn't give fine-grained access to DNS. There's no API into it or anything. So what you have to do is find a way of separating the HTTP traffic from the DNS traffic in JavaScript. So I set out to try and find a couple of ways of doing that. For this example, I'm just going to be looking at exfiltrating a document over DNS through JavaScript. And the only way to really load a document up into the browser is going to be through your typical DOM form input type file. So that's how you can get the file into the system. And the first thing you have to do is break it down into a binary string and encode that into your legit DNS characters, which is the modified base64 form I showed you a while back. So you have your binary string, you compress it, encrypt it, and base64 it. Then you can break that into labels that you can stuff into multiple queries to exfiltrate out. Now there's something called DNS prefetching that's been coming around the last couple of years, and what it does is it resolves domains ahead of time so that HTTP requests will be quicker. Typically, whenever a request is made, say for an image on a website, it first has to make a DNS request before it can make the HTTP request. Well, now what they're doing is they're resolving all those domains ahead of time so that when an image or you click on this is primarily for anchor elements. When you click on an anchor element, it's not going to have to send out that DNS request first. It can just send out the HTTP request. And this is pretty much now implemented on all browsers. And you can one thing you can do is hard-code it into the head section and say, we're going to need all of these domains, so go ahead and prefetch them immediately. And while this would work, it's going to require multiple steps. You're first going to have to generate all these statements, and then you're going to have to load it up in a new file in the browser. And it doesn't offer reliability or two-way communication. It's just going to be a one-shot, spit all the DNS queries out. So instead, how I went about doing this was I'd actually dynamically create these anchor elements with JavaScript. And what happens is when you dynamically create an anchor element, set the href on it, and then the second you add that to the body of the document, it'll shoot off the DNS request to prefetch that. So it actually separates it out from the HTTP request, so then you can use that to control all your queries. But this still doesn't let you do any sort of bidirectional communication. But it does give you a way of doing this dynamically in your code. One thing you'll also want to do is mitigate the amount of DNS traffic you're sending, so you also want to implement some sort of sleep function or use set timeout. And I have a fun